Okay, so moving forward, let's talk about real levitation. Not the Hollywood levitation, but the real one. What would the real levitation look like from a physics perspective? If somebody were to levitate by generating a strong enough holy force or spiritual uplift, strong enough to balance gravity so that the net force acting on you is zero, so you would start hovering around, right? What would that look like in reality? It would not look like
You'll shoot straight up.
it would not look like the way it does in the movies or on stage, for that matter. If somebody's levitating like that, the person is not going to hover around. And there's a reason for it. The reason is because the Earth is going to spin on its axis. It's not going to spin, it's already spinning on its axis. So the Earth is spinning on its axis in this direction. And it's spinning roughly about 1,000 miles per hour. All right, so this is about 1,000 miles per hour. You're also moving with the Earth at the same speed, which means that you got inertia. If you could just cancel gravity, you would keep on moving in a straight line at a constant speed. Remember what would happen to the moon with that? If the gravitational force acting on the moon suddenly and magically vanished, it would move on a straight line. It would move in a straight line at a constant speed away from the Earth. Same thing would happen to the levitating yogi. All right, so he's going to get projected into space. He's going to keep on moving in a straight line at a constant speed about 1,000 miles per hour. Within less than 10 minutes, he would hit space basically. So the physicist,
because you'll be sailing off the planet at an increasing and accelerating speed.
Right. So this is coming from a skeptic. The skeptic says increasingly accelerating speed. There's no such thing. You would move on in a straight line at a constant speed, no acceleration. All right. You would maintain that initial motion in a straight line.
Continue in a tangent path, a straight line away from the surface of the Earth, gradually gaining altitude. You would not come around the world and land on some other spot. You would go flying off into space as the tethers of gravity were cut. That would be where the least mass instead of downhill.
So here's your levitating yogi roughly about 10 minutes later. You'll be projected out into space.
Where you would eventually end up is where gravity was most uphill.
Not really. Once again, this guy's a skeptic. He doesn't know his physics.
Instead of downhill.
Not really. If you don't experience gravity, uphill gravity, downhill gravity, it's just trying to use Einstein's theory of gravity. Nonsense, nonsense, nonsense.
If you were to fall away from the Earth or away from the source of gravity, you'd go to the highest point, and that would be where the least mass in the universe is, perhaps.
Science fiction.
It's hard to say.
It's very easy to say.
The universe is a big place, and there's mass everywhere.
Keep on moving in a straight line at constant speed. Hit one of these, bounce off, go in a different direction.
But surely you find a place of balance.
There's no place of balance in the universe, guys. Look at your lives. Everything is in motion.
This is fraught with difficulty, this levitation business. It sounds good, but it's just...
All right, so this guy's biased. He's not a believer. The only thing we know is if you could just literally levitate, you're not going to hover around. Just remember that. You'd be projected out into space. So if that's the case, now we can analyze this.
Rather than try to disprove this one thing, which doesn't fit into our current scientific paradigms, why not assume that it was true and let that become the seed that then opens up a complete understanding of human potential that includes the ability to float in the air and to fly, and that...
He doesn't say that it's possible. He says there's no doubt that it is possible.
And that it's made possible through the laws of quantum physics.
Using quantum physics, he says it's possible.
These laws, he claims, allow mind to take control over matter.
Mind over matter. Levitation. Yogic style, Indian yogis have been doing it for hundreds of years, according to my dad. And this guy says, yeah, it's doable. As far as he's concerned, he says no doubt it's doable, which means that it's 100% doable. How could that be?
The first thing we have to recognize is...
All right, so he says it's doable. Most of you guys will say it's not. All right, so let's do a comparison. So you guys are college students. This guy's a physicist. You guys are community college students. This guy is a physicist with a PhD in physics. You guys are community college students. This guy has a PhD in quantum gravitational field theory. His expertise is gravity. And you guys are still at community college students taking a freshman level physics. And this guy has a PhD from Harvard. All right. And you know, it's just think of everything that's done up to this point, guys. How often were you right in everything that we've done up to this point? One thing you had going for you was your common sense, and your common sense is a lousy tool. For whatever the reason you have it, it's useless. It always handicaps you in a lot of decision making, and for whatever the reason, you just hang on to it. They just hang up to you. This guy's expertise is physics, gravity. This guy says it is possible. When he says no doubt it's possible, what that means is 100% possible. And let me just break it down, break the physics down for you guys so that you have an understanding of how this might be possible. Okay, so this is not my field, obviously. I'm not a theoretical physicist. I don't have a PhD from Harvard or whatever. There's enough physics here that should be a pause. Because number one, you think you understand gravity. And all of a sudden, how much do you really understand gravity? Let me ask you this question. The question is this. All objects follow at the same rate of acceleration, right? Why? How would you answer that question on the test? Because I almost made it sound like we kind of know the answer. How would you answer that question on the test? Damn it. How would you answer it? All objects follow at the same rate, so the question is why? No one knew how to answer it, and Newton comes along, and Newton says, blah, blah, blah. Hey, take a look, he says. Boom, and then boom, boom. And hence the reason why you got an extra boom here. That's it. So the weight is caused by the force of gravity. Masses cancel. Mass of the falling object is going to cancel. And then the only thing that's left over is the mass. It's going to be related to the mass of the planet. It's going to be inversely related to the size of the planet, square of the size of the planet. My question is, how come the mass of the falling objects not matter? How come the mass of the falling object does not matter? How do you answer that question? I mean, that question is really not answered here. It's really, really pissy. We did all this math, and the mathematics just told us what we knew before. We knew that the mass of the falling object didn't matter. The mass says, it doesn't matter because guess what? It just cancels out of the equation. I'm just as close as before now. I knew the mass of the falling object didn't matter. The mass says it doesn't matter. I still don't know why it doesn't matter. All right, magically, for some unexplained reason, what matters is the mass of the planet, and for some reason that I still don't understand, what matters is the size of the planet. What happened to the mass of the falling object? If a homeless person came up to you and asked you that question, what would you say? You can't just say, hey, you know, it's just in the derivation, the mass of the apple drops out. Are you kidding? That's how people get mugged on the street. All right, you can't say that. It's just a mathematical thing. It's just the math somehow just works out in such a way that the mass of the apple really doesn't matter. It's just simply going to cancel out. What is the conceptual explanation for it? I got news for you. There isn't any. There isn't any. All right, this is the best explanation that Newton was able to come up with. This explanation does not explain how gravity works. It just describes gravity. It's a description of what gravity is. We don't know. Magically, it's related to the mass, and magically, it's related to the size. We don't understand why the mass of the apple does not matter. It just magically gets canceled out of the equation. It's magic, 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 magic. When you go from concepts to the mathematics, you gain absolutely nothing. You gain absolutely nothing. Except out of math, you end up getting these weird predictions. And there you go, okay, so magically, we don't know how fast the objects fall is going to be magically related to the mass. And magically, once again, we don't know how fast the objects will fall depends on the size of the planet. It's inversely related to the square root. There's no explanation. It's weird. There's no explanation. On top of that, you got this constant. All right, nature has like 20 constants like this. You got the universal gravitational constant. Universal gravitational constant is weird. It's weird because number one, it's really, 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 really weak. You got 10 zeros before you hit the first number. This is the strength of gravity. Let me tell you how small this number is. Let me just put it down so you can see it. This number that you're looking at, let's put it onto the next page. All right, this number that you guys are looking at, capital G, is almost zero. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros, and then you have 6, 6, 7. All right, this is it. This number is almost zero. All right, so let me express this number in a different sort of way. Now think of a single penny, one single penny. All right, in terms of a dollar. Focus on this number. All right, so here's a single penny, and here's the strength of gravity as a number. Notice that this number, the magnitude of this number is less than a penny in your pocket, guys. The magnitude of this number is less than a penny in your pocket. All right, so the strength of gravity, the magnitude of the strength of gravity is less than a penny in your pocket. If you got less than a penny in your pocket, what do you have in your pocket? Nothing. If you got less than a penny in your pocket, what do you have in your pocket? Nothing. Strength of gravity is almost nothing. Can you overcome something which is almost nothing? Mind over matter? Yes or no? Is it possible that you can't, you've never done it because you don't believe in it? All right, guys, this is your life goal right here. Can you overcome a number which is almost zero?
Yes.
A number which is, you just like, oh my gosh, I could completely see how Trump became president. All right. it's just a mind game. All right, this is, you don't even need to have a PhD in physics. All of a sudden you look at it, you say, damn, I mean, it's a miracle that gravity exists, because this sucker is just almost non-existent. All right, so the question is, can you overcome it? All right, so